Hello students, welcome to EPG Pathshala. I am Dr. Renu Tyagi from Sardar Patel Institute, Ahmedabad. Today we will study the module Methods of Studying the Body Composition from the paper Human Growth, Development and Nutrition. Let's see the objectives of this module or what we are going to learn from this module. We'll try and understand the need of assessment of body composition in our day-to-day life. We'll then understand the two basic methods of assessing the body composition. Then we'll try and understand the basic principle, methodology and applications of these methods. The body composition and growth are the key component of the health nowadays. The current prevalence of increasing obesity among children as well as among adults has highlighted the importance of body fat in our life. However, the other components of the body composition also influence the health outcome, and its measurement is increasingly considered valuable in the clinical practices. Now, there are growing evidences which links the body composition with the health risk together. The Crockton, for example, indicated that although the individuals of a given height could have similar weight, they could still differ in the proportion of the bone, muscle and fat they are carrying. Benke et al. Reported that excessive weight for height and age could be regarded erroneously among people as the obesity. So, by determining the specific gravity of the football players who ranged in age from 170 to 260 pounds, they found that 11 out of the 17 overweight players were classified within the low fat categories. Another scientists, Keyes and Brozek, corroborated these results, and they also found that the subjects were found to be misclassified by the insurance scales when measured through the body composition methods of evaluation. Besides, the new research also suggests us that the longevity of the human life can be increased further by losing the fat and not by losing the weight. Addition to this fact, the body composition is very important in the athletic performance. The body composition techniques are now very important, and they are not only laboratory procedures, but they are being used in the ordinary medical practices, health clubs or even at homes. A person's health status can be more accurately assessed by measuring the body composition of that individual. Also, the effect of the dietary and the physical activities programs can be better directed. Therefore, it becomes very important to study the body composition nowadays. Let's have a look at the different methods of studying the body composition. The body composition can be studied by the direct assessment as well as by the indirect assessment. Let's see what is the direct assessment of the body composition. Two approaches directly assess the body composition. One technique dissolves the body in a chemical solution to determine its mixture of fat and fat-free component, called as chemical dissolution method. The other is physically dissecting, or that is the cadaver technique, to assess the fat, fat-free adipose tissue, muscles and the bone. Considerable research has chemically assessed the body composition in various animal species, but few studies have directly determined the human fat content. These direct assessment of body composition methods are labor intensive and tedious, as they require the specialized laboratory equipment and involve ethical questions and legal hurdles in obtaining the cadavers for the research purposes. Direct body composition assessment suggests that while considerable individual differences exist in total body fatness, the composition of skeletal mass and the fat-free and fat tissues remain relatively stable. Researchers have developed some mathematical equations to indirectly predict the body's fat percentage on the basis of the assumed constancy of these tissues. Now let's understand what are the indirect assessment methods of studying the body composition. There are various indirect procedures to assess the body composition. One involving the Archimedes principle applied to the hydrostatic wing, also referred as the hydrodensitometry or underwater wing. This method computes the percentage body fat from body density, which is the ratio of body mass to the body volume. The other procedure predicts the body fat from the skin fold thickness and the girth measurement. X-ray, total body electrical conductivity or bioimpedance analysis, near-infrared interactance, ultrasound computed tomography, and magnetic resonance imaging are some of the other methods to estimate the body composition indirectly. Some of the other indirect assessment methods of the body composition are the magnetic resonance imaging, ultrasound, and computed tomography under the imaging methods, and the anthropometric methods includes the weight height indices, the skin fold thicknesses measurement at various sites in the body, and various body circumferences and diameters and breadths, which can be used to find out the body composition. Now let's have the idea of densitometry technique to assess the body composition in little more detail. The body density is equivalent to the ratio of its mass and volume, that is density is equal to MA by V. It is inversely related to the body fat content, that is greater the proportion of fat, the lower is the body density. Therefore, the body density permits an estimate of the percentage of body weight, that is the fat. The term densitometry refers to the procedure of estimating body composition from the body density. It involves several methods, and one of the most widely used is the hydrodensitometry or underwater wing. This method is basically used to measure the body volume. In this method, the subject sits in a specially constructed tank on a suspended chair or frame. This method required a high degree of water confidence, as subject has to exhale all the air before submerging in the water. After that, based on the Archimedes principle, it computes the body volume as the difference between body mass measured in air and the body weight measured during the water submersion. The body volume equals loss of weight in water with the appropriate temperature correction for the water density. The formula which can help us to compute the body density from the underwater wing variables is density is equal to mass upon volume. The equation used to estimate the body's fat percentage incorporates the whole body density. The simplified equation derived by the Berkeley scientist William Siri substitute 0.90 gram per centimeter cube for the density of fat and 1.10 gram per centimeter cube for the density of the fat-free tissues. The final derivation referred to as the Siri's equation, which can help us to compute the percentage body fat. The equation assumes the two-component model of body composition in which the body comprised of fat-free mass and the fat mass. The density of the fat extracted from the adipose tissue equals to the 0.90 gram per centimeter cube and 1.10 gram per centimeter cube for the fat-free tissues at 37 degrees Celsius. However, there are some limitation and error in the hydrostatic weighing. For instance, there is always a air compartment in the body. Besides, the densities of the fat-free mass varies depending upon the ethnic origin of an individual, the age of the subject and the athletic experience or the physical activity level of an individual. Some of the other limitations of this method are that it measures the residual lung volume. Besides, it needs a lot of precision for the underwater weight. In addition, the cost involved in this method is quite high and this technique is non-portable. Plus, we can say that there are very limited type of subjects who can be ready to get themselves immersed in water and hence poses another limitation to this method of assessing the body composition. Now let's have another method of assessing the body composition. One of the air displacement method is the air displacement Tomography. This is an alternate method to the hydrodensitometry which has potential clinical values. This method is simply based on the classic gas laws and does not require the water submission. This technique, commonly called as ADP, is a BOD pod that also use the principle of densitometry to determine the body composition. The BOD pod measures the body mass using a very precise scale and volume by sitting inside the BOD pod. The BOD pod differs from underwater weighing as it uses air as an alternative of water to measure the body volume based on the physical relationship between pressure and volume. The BOD pod consists of two chambers. The molded seat inside the BOD pod divides it into two chambers, namely the front seat and the rear chamber, and provides a common wall between these two chambers. A diaphragm is mounted on the common wall for oscillation during testing by computer control. During the body volume measurement, the BOD pod door is closed by a series of electromagnets and a seal, and the diaphragm effectively moves back and forth between the two chambers. When the volume of one chamber increased, the same amount of volume decreased in other chamber and vice versa. The change in the volume affects the pressure in both the chambers, leading to the magnitude of pressure to change. During the body volume measurement, the subject is advised to breathe normally. Thus, the relevant measurement of lung volume for the BOD pod is not residual volume but the average lung volume during normal tidal breathing. This is much easier measurement to obtain and no difficult maneuver are required. To achieve optimal accuracy, the volume of air in the lungs must be determined, which may be done either by directly measuring the average thoracic lung volume or by using an estimated value based on standard prediction equations. The other method of assessing the body composition is hydrometry. As we all know that water is the largest compositional component of the body. It marks up to 70 to 75% of the weight at birth, but less than 40% in the obese adults. This method of assessing the body composition of the hydrometry works on the dilution principle. Dilution is a method to determine the total body water content, that is TBW, by administration of a tracer and measuring the tracer's concentration a short time later. After collection of the body fluid to measure the pre-dose background level, a tracer of labeled water, which could be tritium or deuterium or oxygen, is administered, and after a short period of time, another sample from the body is obtained. The total body water is calculated on the basis of measured dilution of tracer element and the assumed exchange rate of a tracer with non-aqueous compound. The limitation of this method is it's a high isotope and analysis cost. Besides, the time necessary for the preparation and administration of the sample is another limitation of this method. The precision of the total body water measurement depends on the analytical method as well as the dose of the tracer administered to the subject. In general, the mass spectrometric methods have been the most precise. Using the two isotopes, the precision is 1 to 2%. However, using the other analytical method, the precision is between 2 to 4%. The procedural variations, such as the physiological fluid selected for sampling equilibration time, the estimated correction factor for the isotropic dilution space, and the method selecting for assessing the labeled water may all contribute to the increased technical error, posing the limitation to use this method. In 1958, the Kulwich, Feinstein and Anderson correlated natural potassium concentration with the fat-free mass in the body. In human body, naturally distributed radioactive potassium present in three forms of isotopes, that is 39K, 40K and 51K. The total body counting or total body potassium measures the amount of potassium 40K in the body. Potassium is found almost entirely within the cell bodies. Measuring the amount of potassium in the body can provide us an estimate of body cell mass. And once the total body potassium is known, the fat-free mass can be calculated assuming some constant concentration of potassium in fat-free mass. To measure the 40K in human body, there are three general criteria. A gamma ray detector can be used and it can be placed close enough to the subject. The gamma detector used should have proper shielding to reduce the other natural cosmic and radioactive rays. Also, to identify the gamma rays among 40K, a computerized analyzer should be present in the system. The other method to assess the body composition is neutron activation analysis. The first demonstration that human body composition can be analyzed by using the neutron activation was reported 40 years back. These techniques are highly accurate for time-specific body composition, with a typical body scan occupying up to 1 hour. As the subject has exposed to a neutron field, output of gamma rays can be measured as the cell nucleus relaxes and again go back to its pre-exposed state. The gamma output can be measured immediately after activation or at a somewhat delayed period. Using these techniques, many elements in the body can be measured like the carbon, nitrogen, sodium and calcium. A significant concern with these techniques is that these techniques involve high level of neutron radiation exposure and therefore has not been used in large scale population research. The another indirect method to assess the body composition is the DEXA technique or dual energy X-ray absorptiometry technique. This is used to measure the bone mineral and soft tissues composition of the body. It provides estimate of the composition of total body and of the specific regions in the form of bone mineral, fat-free soft tissues and fat. This method requires a low radiation exposure in the form of two photon beams, one of the low energy and other of the high energy, which passes through the body. Radiation exposure with the DEXA is low of about 0.05 to 1.5 mRAM, depending on the machine and the speed with which the total body scan is done. The DEXA scan takes about 20 minutes, but some of the updated machines can complete a whole body scan in 5 minutes. The DEXA unit measures the attenuation of the low dose of X-ray beam as it passes through different tissues of the body. The amount of the photon beam absorbed by the atom in bone mineral and soft tissues of the body is recorded during the scan and converted to estimate bone mineral and soft tissues. The DEXA instrument must be linked with the appropriate computer algorithms to measure the bone mineral, fat tissue content and the fat-free soft tissue content of the total body. Another most popularly used method to assess the body composition is the bioelectrical impedance method, that is the BIA technique. The bioelectrical impedance analysis is a method of assessing the body composition and it measures the body fat in relation to the lean body mass. The human body has a tendency to conduct an electric current. The aqueous tissues in the body have dissolved electrolytes. Because of that, they are considered as the conductors of an electrical current, whereas the body fat and bone have relatively lower electrolytic content and hence poor conducting properties. This difference in the electrolyte content permits an estimate of fat-free mass from the magnitude of the body's electrical conductivity or from the body's impedance to an electrical current as it flows from the source, usually the ankle, and the sink, usually the wrist electrodes. The fat-free mass has high conductivity and low impedance, whereas the fat mass has low water and electrolyte content and has low conductivity and high impedance. The basic principle behind the BIA technique is that the impedance is the frequency dependent opposition of a conductor to the flow of electric current. Impedance is a vector quantity which consists of two independent scalar quantities, that is resistance and reactance. The general theoretical model of BIA, that is bioelectrical impedance, treat the human body as a single cylinder with the measurements made between electrodes placed on the wrist and the ankle. The adjustment of the bioelectrical data for the height allows the estimation of total body water. In practice, the empirical derivation of the regression equations relating height squared to the impedance to total body water is required and these equations are applied to predict the total body water, which is converted to the fat-free mass. The imaging methods are considered to be the among most accurate approaches for in vivo quantification of the body composition. Some of the most widely available methods are ultrasound imaging, X-ray computed axial tomography, that is CAT, and the magnetic resonance imaging, that is MRI. The ultrasound is most of the familiar and oldest technique of the imaging among all the three imaging methods. In this method, the ultrasound rays reflect from the boundaries of the body tissues, which are interpretable by a trained technician. The kind of image or the image quality in this method may be poor, but it is widely used for the evaluation for measurement of adipose tissue deposited on the tissues of the body. The ultrasound imaging is free of hazards. That is why it is useful in the assessment of human body composition. Detecting the differences in adipose tissue distribution can be more explored by using this technique in details. Now let's have a look at the computed tomography in details. This method generates the detailed cross-sectional two-dimensional radiographic images, where X-ray beam passes through the tissues of different densities. And this provides us the quantitative information on the total tissue area, the total fat and muscle area, and the thickness and volume of tissues and organs. Now let's study the basic principle behind the imaging method, especially the computed tomography technique. In this technique, an X-ray tube and detectors are located at the opposite poles of a large ring, where a tube rotates around the table. The subject is made to lie with arms stretched above his or her head. A computer connected with the subject generates an image from the attenuated beams to recognize the tissues and hence to create an image. Now let's have a look at the magnetic resonance imaging technique in more details. As we all know that the atom and the molecules in human body are in random orientation as the magnetic field of earth is very weak, but when the human body placed in a strong magnetic field, some of the nuclei will attempt to align with or against the magnetic field. The hydrogen proton in particular have a high affinity for alignment with the magnetic field. After the hydrogen protons are aligned in a known direction, a pulsed radio frequency is turned off. The proton gradually returns to the original state, in the process releasing energy that is absorbed in the form of radio frequency signal. The magnetic resonance imaging or MRI system use this signal to generate the cross-sectional images. During MRI imaging, the subject must hold his or her breath to reduce the effect of respiratory motion on image quality. A series of images for whole body analysis can be acquired in less than 30 minutes. The advances in the scientific studies has made MRI a much more useful instrument for body composition research. A major advantage of the technologies like magnetic resonance imaging and the computed topography is the lack of ionizing radiation. The radiation exposure is still a concern in long-term longitudinal studies with repeated measurements over time, and the study of children and women in childbearing period. While comparing the CT with MRI technique, the MRI method is slightly overestimate subcutaneous adipose tissue volume and underestimate the visceral adipose tissue volume. But the MRI can be considered sufficiently accurate for measurement of adipose tissue volumes in assessment of the body composition. The MRI machine can be clearly seen in this picture, which is used for the technique of imaging. Let's see how anthropometry can be a good tool towards the assessment of body composition. Decades ago, anthropometry was the only technique present for quantifying the body size and its proportions. The anthropometric measurements like the skin fold thickness, circumference and body length and body width were used in developing the equations for predicting the body fat among people. The science of anthropometry provides the simple approach to body composition. The anthropometric equipments are portable and relatively inexpensive. Also, the anthropometric procedure are non-invasive, so they can be easily practiced in the field conditions. However, the anthropometry requires adequate training by an experienced professional and quality control, including the analysis of inter and intra-observer reliability and the calibration of the equipments or instruments during the study or during the course of the work. A number of height, weight indices have been proposed in the literature. You must have heard about the body mass index, that is the BMI, which is most widely used index, and it has been recommended by the World Health Organization as a crude indicator of the nutritional status of the population. The adults are also categorized into the different BMI categories as per their BMI values. They can be classified as underweight, normal weight and overweight or obese as per the BMI or their body mass index values. For example, a person having a BMI less than 18.5 kg per meter square is classified as a underweight individual. However, the people ranging between the 18.5 to 24.9 kg per meter square values of BMI are classified as the normal individual. And the individual who have a BMI value of more than 25 kg per meter square are classified as the obese individual. The children are also screened as per their weight for height standards and the body mass index values, or as the age reference charts, due to the discrepancies rate of the growth. So it's used as the adiposity marker in identifying the individuals at risk of the metabolic disorders or developing the metabolic disorders. However, their utilization has been debated as a consequences of inability in distinguishing it from the fat-free mass. Now let's have a look at the height weight indices, which can be used to assess the body composition. A number of height weight indices have been proposed in literature, that is the body mass index, which is most commonly used to assess the body composition. The body mass index is the most widely used index and has been recommended by the World Health Organization as a crude indicator of nutritional status. The children can be screened as per the weight for height and BMI for age reference chart due to discrepant rate of growth. It is used as a adiposity marker in identifying the individual at risk of metabolic disorders. However, its utilization has been debated as a consequence of its inability to distinguish the fat mass from the fat-free mass. Let's have a look how the skin fold thicknesses can be utilized to assess the body composition. The skin fold thicknesses are widely accepted as the measurements of the body fatness because of the two reasons. Number one, they makes about 40 to 60% of total body fat. And number two, the skin fold thicknesses can be measured directly by using a well-calibrated caliper. The most often used skin folds for the assessment of total body fat are the biceps, triceps, subscapular, suprailiac and abdomen. Despite relatively strong correlations of the skin fold thicknesses at a single site with body fat percentage, no single site is accurate predictor of the percentage of body fat, reflecting the inter-individual variation in distribution of subcutaneous adipose tissue and the proportion of total adipose tissue under skin. The tricep skin fold thickness is the highly sensitive to the nutritional status and hence used directly as an indicator. As per the literature, the four different calipers have been used to study the skin fold thicknesses. Some of the advantages of using the skin fold thickness technique are that this technique is quite inexpensive, it's quite fast as well as portable and can generate a large database. Now let's see how the circumferential measurement and breadths can help us to study the body composition. In past few decades, more than 17 sites for circumference measurements have been used in equations for predicting the body fatness. The mid-arm, mid-thigh, waist and hip circumference are the most commonly used and most commonly used circumferences because they indicate the difference among the people in major regions of the body. The circumference measurements are considered more reliable than the skin folds and can be measured irrespective of the body size and the fatness. Besides, a simple steel tape can be used to measure the circumferences at almost all the sites. The skeletal breadth along with the length is distinct determinant of the fat-free mass. Measurement of the bone breadths at waist, elbow, ankle and shoulder using the suitable caliper are used to measure the growth among children. While in adults, they provide the information on the individual frame size. Let's have a look at this picture which can show us that how anthropometry can be used to assess the body composition. As we can see from the picture that the body circumferences, the skin fold thicknesses and the body widths are clearly marked here to assess or take the measurement in order to finally study the body composition in human being. So students, let's summarize what we have learned so far in this module. We have understood the concept of body composition and its importance in the assessment of the body proportion. The body composition analysis of the fat and the lean component of the body can be determined through the direct as well as the indirect methods in the research. The direct methods include the cadaver analysis or cadaver studies, whereas the indirect measurement of the body composition can be the densitometric method, dilution method, total body nitrogen amount, total body potassium content, the X-ray method, computed tomography, or it can be magnetic resonance imaging, or it can be ultrasound method, it could be a electrical conductivity evaluation, it could be the photon absorptiometry, it could be the air displacement method, or it could be the anthropometric measures. However, after studying all these methods in details, we have realized that the anthropometry is the most reliable, most practicable and the economical method for the field studies. Thank you.